Hello everyone, welcome to Appendix 2, and this is going to be a chapter on VPC, which is basically the networking service provided by AWS. This is going to be our agenda. I'll start with networking 101, then we'll talk about what VPC is, followed by network address, so how VPC contains a network address, and then subnet, route table, security group, which is basically a firewall for the EC2 instances that will launch in a VPC, and then NAT gateway, VPC endpoint, and VPC peering. If you already know what VPC is and if you have already worked on AWS, you can completely skip this section or skip this entire appendix because the topics are going to be very basic. I'll only cover the essential networking concepts which are needed by data engineering. I'll not go deeper into multiple networking concepts. So if you choose to, you can skip this entire section also. Okay, so before talking about networking, let's see how networking at home works. So you are watching this video using a laptop and over the internet. So of course you have internet connection. So how do you connect your laptop to internet at home? So the component that is used to connect to internet at home is basically the router. So what happens is that router connects to the internet via the internet service provider. Now next, what router does is it creates an environment within the home, meaning it creates a boundary within the home and all the devices that you use come inside of that boundary. If you have a laptop and you are connected to the Wi-Fi, then it would come under the router's boundary. So let's say you have a phone or multiple phones and you are connected to Wi-Fi or the router Wi-Fi, then also it actually falls within the boundary of the router. There are various router components. The most important component for a home router is the internet gateway. Now what is internet gateway? It is a program that runs inside of the router, and internet gateway is responsible for connecting to internet. So all the traffic that goes to internet from your machines and devices and all the traffic that comes from internet to the devices that you have happens via internet gateway only. So if you do not have internet gateway running in your router, then you will not be able to connect to internet at all. Router also has a network address. So if you type ipconfig or fconfig in your machine, you'll see that you'll get an IP address. So that IP address belongs to the network address which is provided by the router. Now as I said, router creates a boundary. The definition of the boundary is provided by the network address. Router also has something called route tables in individual machines. Now what is a route table? Route table basically maintains a path or describes a path which can be used to go from one machine to another machine, or let's say one machine to internet or one machine to another machine in internet. That's what route table does. Then we have firewall also. Typically in home router we do not have firewalls unless we install VPN. But in corporate networks and in AWS, obviously there would be firewall. Now when you talk about corporate network is also similar, but it is at a much larger scale. And there can be multiple routers available in the corporate network. Okay, so now what is VPC? The full form of VPC is Virtual Private Cloud. So as it is virtual private cloud, it is virtual. So VPC is basically a virtual router at AWS and it spans the entire region. So let's say we are using region US East 1 or North Virginia, and if we create a VPC, the VPC will span the entire region. So the presence of VPC would be there in the entire region. When I say entire region, the physical presence of the region is manifested by the availability zones or AZs. So the VPC can contain one or more AZs. So let's say we create a VPC and we choose to put AZ 1, 2 and 3, which is US East 1A, 1B and 1C in the VPC. That is fine. So in this way we are actually opting data centers like US East 1D, 1E and 1F out of the VPC. So a single VPC can contain one or more AZs. So in this case, let's say the VPC that we create would contain only AZ 1, which is US East 1A, and AZ2, which is US East 1B. And of course, we can create multiple VPCs in one region. So multiple VPCs can be for multiple customers, can be for same organization, but multiple departments. That is also fine. Now, as VPC is a virtual router, obviously, just like the home router, VPC would also have certain components. So what are those components? We have network address, just like the home router. Then we have internet gateway. Now, internet gateway in VPC does not come automatically. We'll have to create it separately and then attach it to the VPC. So you don't get internet gateway by default running in the VPC. Then we have route tables, which tells us how to route the networking traffic to various devices or various networks or to internet. Then we have subnetworks or subnets. So unlike router, wherein we have all the devices inside of that router's boundary, that is not possible in VPC. So in VPC, we'll have to create subnetworks, and then only we can actually launch instances, launch RDS instances, EMR clusters, Redshift clusters, etc. inside of those VPC in those subnets. So this is the diagram of the VPC components. So first we have VPC, which spans the entire region. VPC should have an internet gateway also, and we create that internet gateway separately and attach it to the VPC. Now we can have multiple AZs inside of that VPC. In this case, I have chosen US East 1A, 1B and 1C, and the subnets would be there inside of the AZs. So in this case, US East 1A has two subnets, subnet 1 and subnet 2. US East 1B has one subnet, subnet 3, and US East 1C has three subnets, subnet 4, 5 and 6. And then we launch the resources inside of these subnets. Then we have route tables, and the route tables are actually associated with the subnets. So single route table can be associated with multiple subnets also, or one subnet can have multiple route tables also, or each subnet can have only one route table as well. So these are the high level components of VPC that we are going to discuss. Now the next thing is that when you create a VPC, we need to provide a network address. So what is a network address? Network address is basically an IP address or address to keep devices inside of it. So let's go ahead and run ifconfig or ipconfig in one of the EC2 instances that we launched earlier. You'll run ipconfig if you had launched Windows EC2 instance. That we did not do, but anyway. So this is the EC2 instance, and let me run ifconfig. And if you see, there are two things. One is Ethernet and the other one is loopback. We are not bothered about this, but here, this is actually the IP address of this EC2 instance, which is 10.0.2.64, and it is showing something called netmask. We'll talk about netmask later on, but let's understand the IP address, what this IP address actually means. Each one of these numbers which are separated by dot are called octets, and the size of each octet is 8 bits, meaning that you can only have value from 0 to 255 in a single octet. So you cannot have, let's say, 300 dot something, because that is beyond 255. 8 bit cannot store more than 255, so each octet can have value from 0 to 255. That's what this IP address represents. Then we have something called netmask. So netmask tells us or gives us a glimpse about the network address. This is the IP address of the machine. So as the machine or the EC2 instance is inside of a network or a subnet, how do we find out the network address of the subnet? And netmask helps us there. If you see, the netmask is 255.255.255.0. It means the entire 8 bytes of the first 3 octets are filled. This implies that 10.0.2 actually belongs to the network address. So the network address would be 10.0.2.0/24, because initial 24 bits belong to the network. That's what the IP address and the net mask combined together signifies. So as I said, let's dig deeper into the IP address and find the network address. So each octet is 255 bit long, and the network address is actually CIDR notation. The full form of CIDR is classless interdomain routing. It can be something like this: IP address followed by /8, /16 or /24. So these are the 4 octets that we have seen. In our case, it is 10.0.2.64, and each octet is of size 8 bits. Now if I divide it by 3 dots, these are the 3 dots. And when you mention the network address to be /8, it means that the first 8 bit belongs to the network and the last 24 bits belong to the device. So we can have 255 into 255 into 255 devices in this network address, which is /8. In our case, the network address is 10.0.2.0/24. Why 24? Because netmask says that initial 24 bytes belong to the network. So that's why it is 10.0.2.0/24, and in 24 you cannot have more than 255 devices. But with /8 we can have 255 into 255 into 255 devices. Now if you go back to the EC2 instance, had it been /8, then the net mask would have been 255.0.0.0. That's how the net mask would have been if the network address were to be 10.0.0.0/8. Now again, for /16, it means that the initial 16 bits belong to the network and the last 16 bits belong to the device or all the devices that would be put under this network. So again, going back to the EC2 instance, had it been a /16 network address, then the network address would have been 10.0.0.0/16 and the net mask would have been 255.255.0.0. Now why 255? Just to reiterate, because that is the maximum size in 8 bits, meaning all the bits have a value of 1. So that signifies that all bits actually belong to the network. Then for /24, which is the case that we have seen, the initial 24 bits belong to the network and the last 8 bit belong to the device. So that's why our device number or the EC2 instance that we have launched inside of that network, whose address is 10.0.2.0/24. Why 24? Because netmask is 255, 255, 255, 0. 8 bits of the first octet, 8 bits of the second octet, and 8 bits of the third octet. So initial 3 octets belong to the network and the last octet belong to the device. So in our case, this EC2 instance has a number of 64 inside of this network 10.0.0.2 or 10.0.2 rather. If you have any questions, of course, we can discuss it in our live session or live discussion. Please go through it multiple times and come up with any questions that you might have. Then the concept of subnets. As I said, that EC2 instances cannot be launched inside of VPCs directly. So you have to create subnetworks inside of that VPC. So subnet is nothing but a smaller network address than VPC. So if the VPC address is, let's say, 10.1.0.0/16, this is the CIDR notation of the VPC, and this is the network address of the VPC, the subnet range can be anywhere from 10.1.1.0/24, 10.1.255.0/24. So this can be the first subnet range, and we can have a maximum device of 255 less than some of the system used IPs. For example, 0 is used by the router, 255 is used for broadcasting, and there are some additional IP addresses which are used by the system. So typically you get anywhere between 250 to 252 devices in a single octet. Then let's say the VPC address is 192.0.0.0/8. The subnet range can be 192.1.0/16 to 192.255.0 255.0/16, and maximum devices can be 255 into 255 because we have last two octets available in this subnet. Subnet range 2 can be 192 dot some value dot 1.0/24 to 192 dot some value dot 1 dot or dot 255.0/24. Actually it is wrong, and the maximum devices can be 255 minus the system used IPs. And there are two types of subnets. One is called public subnet and the other one is called private subnet. Public subnet is something where that subnet can be connected to internet gateway. That means all the devices or all the EC2 instances inside of that subnet can talk to internet. But private subnet is the opposite. There's no internet connectivity of private subnet. So any devices or any EC2 instances that we launch inside of a private subnet will not have any internet connection. The next component is the route table. So what is a route table? Route table is something that it tells you if you have to go somewhere, how do you go? This is again in normal term. So let's say from an EC2 instance or from a subnet, you want to go to another EC2 instance or another subnet, how do you go? Or if you have to go to internet, what should be the route for the EC2 instance to go to internet? And there are two components in route table. One is destination, meaning the location where you have to go, which is denoted by somewhere in the first bullet point. So let's say you have to go to internet, then destination would be actually internet. If you have to go to some other subnet, then the destination would be some other subnet. And then we mentioned the target. Target is the medium using which you have to go to that place, meaning how do you go there. So if you have to go to internet, if you want to send and receive traffic to and from internet, what will enable you to do so? So let's say we have this EC2 instance, and EC2 instance is inside of a subnet, and we want to send traffic from EC2 instance to internet. So how do you go there? The internet would be the destination and EC2 instance would be the source. And now if you have to go to the internet, we know that we need internet gateway for that. So internet gateway would be the target. And then we'll create a route table and associate that route table with the subnet, which will mention this particular relation. So if you have to go from this subnet to the internet, you'll have to go via the internet gateway. So that's how a route table is created. And route table can also be public and private. So public route table is something wherein the route table has a path to the internet gateway so that any EC2 instance inside of that subnet can connect to internet. But private route table does not have any path to internet gateway, which means if we assign a private route table to a subnet, none of the EC2 instances inside of that subnet would be able to connect to internet. So that's why if we connect a public route table to a subnet, that subnet becomes a public subnet. And if we connect or associate a private route table to a subnet, that subnet becomes a private subnet.